And a big g'day to everyone down there at Terang and District. It's Graeme Anderson here from Agriculture Victoria with a bit of an update on all things to do with weather, climate and forecasting. So I lead the team in Agriculture Victoria. We put out products like the Break and also support the team that puts out the Milking the Weather newsletters, which is really about just providing good commentary for farmers about making sense of what's coming out of the all of the climate modelers, and also different stuff like soil moisture monitoring probes underneath pastures, just so we can keep track of how much rain we've got in the tank for the spring that's ahead. I'm going to share a few tools. This tool here, it's a ripper. This is called Climate, and you can see it there. You can get it on your desktop or you can download it as an app. So climateapp.net.au. Really good tool. You can select from hundreds of locations. Pick your local site. You can see here I've got Terang, and then just sort of look at how we're going for rainfall so far this year. So it starts from January, go all the way through. You can see all of these are individual years, and then this is the blue line's the long-term average, and the red line is just how we're tracking this year. So we were a little bit behind the 8 ball, but the last month things have picked up. That's good, and it gives you a bit of an idea of how we're tracking compared to longer term. So a good tool, well worth checking out. And with this app, you can also do things like how often, and and interrogate how often has something happened in the past. So here we've just plugged in how often do we get 50 millimeters over 14 days in that Terang rainfall record between 1st of May and 30th of April. So if you're looking for the autumn break, how often has that particular one happened? And it says 57% of years. And you can look at that over the longer term, how often it's happened, and you can probably also notice too that perhaps in the last 20 or 30 years it hasn't happened as much as it did in the prior 30 years. Now here we've got a long-term rainfall record for Terang, goes back to 1897 right through to last year. And up this side we've got millimetres of rainfall, so 400, 600, 800. The long-term average 780 mils, which is this line here, and there's 1,000, 1,200. So you can see plenty of variability over the years, but also that there's a few periods, in the last 20 years there's been 7 wetter and 13 drier. But prior to that, when you look through, say, back to the late 50s, there was a run of wetter years. Some wetter years there in the 50s, and then you can look back perhaps before World War I, a run of dry years. So you can see there's plenty of variability in that pattern. And this is just looking at that rainfall for Terang, but this is seasonal. So that's summer rainfall for that long-term record, autumn and winter and spring. And you can see plenty of variability there. Probably the one thing we point out is that just autumn is the one season which has been misbehaving a bit in terms of the last 20 years. There haven't been too many wetter autumns. Also, perhaps in the last few years, we've noticed with springs, we've had a number that have been, pretty dry. So we'll talk a little bit about what might be behind some of that. So where does all our rain start? Well, here's a really important picture. It's a satellite image of precipitable water that sits in the atmosphere. And you can see that most of it all starts at the equator where the oceans are warmest and it's the hottest part of the planet. And basically, one of the things about forecasts and seasonal forecasts is some years there's more of that moisture drifts down and feeds into our rainmaking process than other years. And this image shows it well. Here we are down here in Victoria. You can see Antarctica. You can see all the cold fronts that whiz around in the Southern Ocean, driven by the southern annular mode. And those cold fronts flick their tails across southwest Victoria. And it's where that cold air hits good feeds of moisture coming in from our warmer oceans to the north. That's why we've got really good reliable rainfall down in southwest Victoria. Now, some years in the Pacific, the El Nino Southern some years there's extra moisture blowing in, and that actually are those wetter years. And some years with an El Nino, the warm water's over here, and there's less moisture feeding into our weather patterns. The same with the Indian Ocean dipole. Some years like 2016, feeding in lots of extra moisture, relates really well to southwest Victoria wetter years when the IOD's in its wetter phase. And then when it's in its drier phase, we tend to have less cloud and moisture up here feeding into a weather pattern. So this is the one we're keeping a bit of an eye on this year because the IOD, a few of the models, I think it's heading into its drier phase. Now here's an important tool that's that forecasters look at. Here's September 2006. It's a dry pattern. This is the sea surface temperature anomaly. So the oceans are a lot warmer along the equator and cooler down here, but this is just showing where the ocean might be about 2 degrees warmer than average, which is this zone here. And then the blue is where there's cooler water than average. And you can see in this situation what's happened is we've got the warmer water over in the Eastern Pacific. There's an El Nino. All the cloud tends to follow the warmest water where that pops up. And now here what we've got in north of Australia is just cooler water, and there'll be a lot less cloud and less moisture to feed into our weather pattern. So that's a dry pattern. Keep an eye on this little area to have a look at what a wet pattern looks like in the next slide. And there you go. You can see this is October 2010. You can see a big La Nina here and really warm water right around Australia. So there's moisture feeding in galore that year to our weather events. So that's pretty much what seasonal forecasting is trying to do. They're really looking at, is this one of those years where there's extra moisture available or not? Now, when we look back at the long-term records for Terang, you know, a third of years will be in the driest thirds, a third are average and a third are wetter. And we're going to have a look at what's been the influence at Terang of those previous El Nino, La Nina and Indian Ocean dipole events. So here we go. You can see for that rainfall record at Terang, instead of a third of years being dry and a third average and a third wet, in the 28 El Nino years at Terang, August, November rainfall really increased the chance of drier. Still shows that you can get average and occasionally wetter, but increase the chance of dry. So that's what's happening in El Nino years. This is what's happened at Terang for August, November rainfall in IOD positive years, and that's the one to watch because it's possibly heading in that direction this year. Just sort of doubles the chance of being in that drier territory. Doesn't guarantee it, but doubles the chance. When it's wetter, the La Nina reduces the chance of drier, and the IOD, like 2016, really does reduce it. It's quite a strong driver for southwest Victoria. So that's sort of part of what's long-term variability. Is there anything different happening now that's not just part of variability? So one thing that is a bit different is temperature. These are summer maximum temperatures, autumn maximum temperatures, and winter and spring for the last 100 years from the Bromets for southeast Australia. But you can see there are anomalies from longer term average. You can just see that in the last decade in most places it's been warmer. Now, warmer or milder winter is a good thing for pasture point of view down at Terang. But one of the things about warmer summers is that it has an impact perhaps on pasture survivability and things like that. Probably one thing to watch is just here when we look at the last 10 years, there's been a number of springs that have been 1, 2 to almost 3 degrees warmer than average, and that's sort of part of just summer starting a bit earlier. So that's part of modern day variability where things are getting a bit warmer. Here's just some local records from the Cape Otway Lighthouse. You can see maximum temperatures over the longer term there, and certainly things ramping up. So that's a trend that's expected to continue, and it's not just being measured here, it's been measured in most places around the world. And there's some other work that was done looking at seasonality of rainfall and shows sort of the summer rainfall zone and the strong winter rainfall zone, and looked at just rainfall in the last sort of couple of decades compared to the last 100 years. And basically what it showed that those rainfall zones are all shifting south. So we've got some of the uniform rainfall zones shifting into northern Victoria. We've still got winter dominated rainfall zone, but it's sort of largely as expected. The climate zones are shifting south. That's what's happening above our heads. And I guess it's part of the challenge of modern day farming as those climate zones keep shifting. Another thing that's a bit different, if we look at the this sort of area over southern Australia, this is the pressure pattern above our heads from 1950 through to 2015, and you can see that while the pressure pattern varies, there is a bit of a trend line there. And again, that's part of what's in the climate models, is what they expected to see as the world warms up, the pressure in areas like southern Australia just gets a bit higher. So that just means it can squeeze out the odd rain event. Also, when the high pressures sit in the right spot, still means they can drag up really cold air coming from down close to Antarctica. So we can still get some frosty conditions and cold conditions. But part of what we're dealing with is this stronger pressure pattern. So just going to run through some forecast tools. Now, one thing I will say about, say, forecast for the weather, say, up to the next 7 or 8 days, forecasts are getting better, but also no one can accurately predict the future. So you need to be aware that there are different sort of forecasts getting around. And here's an example of a rain event last year where this is the Bureau's model forecast. This is a USA model forecast, and here's a European one. And you can see sometimes the three of the models might have slightly different things. Now, depending on which app or model you're looking at, that could determine what you think you're going to get. So here's a good product. This one's put out by the Bureau, and it's actually on the water and land site, and it's got 6 models. It's got the Australian, US, UK, Japanese, European, and the Canadian models. It puts all 6 of them together to look at the next 1, 4, and 8 day forecast. So it's a good product. So you can see that product here. It's on the Bureau site. It's a ripper. There's also a chart viewer on the Bureau where you just hit play and it'll roll out the next 7 days of the Access forecast, which is another good tool. And there's also Meta, which is another one. But there's lots of other apps and things that are available. Just a key thing is make sure you know which climate model it's drawing from. Now, a really important thing when we move beyond the 8 day forecast is we talk about seasonal forecasts, and no one really knows what's going to happen and no one can accurately predict it, but we're not flying blind either. So what the seasonal forecast models do is they'll run them over a period of 3 months, and depending on how the sea surface temperature is set up and how the pressure pattern's set up, they'll sort of spit out where they think it might rain more or less. Now, here's the current Bureau's model that was issued June 13 for July to September this year, and you can see there for sort of our part of the world there's around about 70% of the models have fallen on drier than average, but it also means that there's 30% have fallen on wetter than average. So the key thing is that they might have run the model 100 times. Well, yes, 70 might have fallen on drier, still 30 were on wetter. So seasonal forecasts can't actually predict exactly what's going to happen. They just tell you if the odds are swaying one way or the other. So another way of looking at that forecast is here's a new test product that is being produced, which is if you're looking at normally throughout history, 20% of years have been in decile 1 to 2, and 20% of years have been in decile 9 and 10, and everything in between. So that 70% chance of dry forecast is probably the same as what this one's looking at, where they might run the model 100 times, and 33 have landed in decile 1, 2. 23 of the model runs have landed in decile 3 and 4, 23 have landed in deciles 5 and 6, and only 8 have landed in decile 9 and 10. So this sort of product shows that really the models are saying any of those options can happen, but more of them are thinking sort of drier than average. And that's probably the best way to think about seasonal forecast, because pretty well anything can always happen. You've got to have a plan for anything, but in different seasons, depending on how the climate drivers are shaping up, there can be the odds stacked one way or the other. There's plenty of work being done to try and improve these forecasts, and especially how they're communicated for farmers. So stay tuned, there'll be some improved products coming. Now, no matter what the forecasts do, farmers do a great job of managing variability, and we've got a lot of modern techniques and R&D and genetics and innovations. We can produce more than ever, and it's credit to dairy farmers how much they do produce. But to deal with seasonal variability and risk, we've got also improved farm and regional infrastructure, and there's certainly been a lot of work done on farms to improve storages of water and fodder, which really helps deal with those certainly the bigger summers that we seem to be getting. Also really important, this variability of income is really important, and as you've sort of seen, that variability flows into feed costs, and it's cheaper to grow your own, but there's also a lot of variability that the other industries are facing in terms of dealing with what's happening from one year to the next. So that's a key thing, good skills to manage business. There's been great work being done through improved sort of land management on farms to make sure we've got good pasture cover and especially not reduced overgrazing, and also just make sure good networks and knowledge channels so that you're in the loop, and as things are changing, you're getting good advice. And hope that's useful. If you want to get those updates, we've got monthly commentary. Drop an email to the break. Also, you've got the Milk and the Weather, which is designed specifically for dairy farmers, and some contacts there if you want any more information. So all the best.